Yeah, good morning to all. I think today is the sixth class now. So totally we need to complete the first unit in 12 hours. So we have the middle of the first unit. Almost we can complete it at the more than 50% we can complete it in the first unit. Okay. So next, what is the recap? Last class, what we can do the last class? Just we can just predicate calculus or predicate logic, quantifiers, free and bound variables. These are the things we can do in the last class. So what do you mean the predicate calculus or predicate logic? Already we can study the proposition. Proposition, nothing but a declarative sentence or statement. Either it is true or false, not both. That is called a proposition. Normally we can predicate. Some variables are given in the statement. So until the variables, we can give the value, it is called a predicate. Once you can fix the value to the variable, it is a proposition. So let P of x is equal to x is equivalent to x is an integer, and the q of x equal to x is either positive or negative. So some example, last class what we can do, one or two examples we can go through, then we move on to the new topic for today classes. Okay. P of x is equal to x is an integer. Q of x equal to x is either positive or negative. Okay, then P of x tends to Q of x is a compound proposition function. Why we can say it's a compound? P of x is a one more predicate and Q of x is another predicate. These two things is connected by a connector conditional. That's why it's a compound. Compound proposition is nothing but connect two proposition by using a connectors. What are the connectors? Connectives we have conjunction, disjunction. Normally some of them in the homework also I can see you can write the conjunction as intersection, disjunction as union. Please don't put like that. You can say it's a disjunction as V, conjunction as mirror image of V, upside down, water image of V. So conjunction and disjunction, don't write union and intersection. That is the meaning is union and intersection, but here we can use symbol as conjunction and disjunction. So conditional, there are four things: conjunction, disjunction, conditional, biconditional. These four we have studied. NAND and NOR, sometimes they can ask you. So then P of x tends to Q of x is a compound propositional function. Obviously, for all x is a quantifier for all. That's why I can give the quantity for all or for some. There are two quantifiers we have studied. One is universal, another one is existential. Universal meaning for all. That is a upside down of A or water image of A. So for all x, another one is a directrix. That is a mirror image of E. That is a directrix. Obviously for all x, if x, that is a symbol is if, then that is a condition. If P of x, if x is an integer, then x is either positive or negative. If x is an integer, then x is either positive or negative. We can say it's a positive integer or negative integer, where the universe of discourse consists of the integers. That is a for all. For example, another example, that P of x comma y, that is a two things are there, nested quantifiers we are seeing. So two things is will become x comma y. X is taller than y. So if x is taller than y, then y is not taller than x. If x is taller than y, then y is not taller than x. That is a converse. Vice versa, P of x comma y, that is if x is taller than y, then there is a conditional. There x is P of y comma x. So y is not taller than negation. You can use it. Negation meaning not. So x is above y. First term is whatever the first you can write first. Here y is the first. You can write y is the first. Y is not taller than x. Y is not taller than first term. You can write first place. Second variable you can write the second place. So you can first place is y. This is x is taller than y. This is y is taller than x. This P of y comma x meaning y is taller than x. This P of x comma y meaning x is taller than y. Negation you can put not taller than x. Y is not taller than x. That is it. Already I told to you for all will come. It is a conditional. If it is a directrix will come, you can write conjunction. In the place is conjunction will come. In the directrix you can write conjunction. For all one more you can write conditional. This is we can did in the last class. Last class I would like to time a free variable and bound variable if we can do. For this places both are bounded variable. Both x are for all x and a bracket symbol is using. Suppose this bracket is not given, only P of x, the first x term, P of x is a bound variable. In the x is q of x is free variable. So some quantity is mentioned, it is called a bound variable. Quantity is not mentioned, then it is called a free variable. So till we can did in the last class, and also the nested quantifiers we have started. So from formula you can go for nested quantifiers. Give more some examples, then we move on to next rules of inference. Translate the statement to the symbolic form. Sometimes they can write translate the statement for all x. English sentence we can convert. Symbolic form question itself is given. For all x, c of x, conjunction, there exists a y, in between bracket plus c of y. There exists will come. That's why I told you. There exists will come, you can write conjunction. For all will come, you can write conditional sometimes. So there exists a y, c of y, conjunction, f of x comma y into English. This is a symbolic form it is given question. We can convert it into English form. Sentence statement we can write. Okay. Well, what is the given c of x? C of x is x has a calculator. What do you mean by x? Finally, they are in the school. Yeah, x and y are consisting of all the students in your school or college. X has a calculator. F of x comma y is x and y are friends. X has calculator. F of x comma y is x and y are friends. And the domain for both x and y consists of all students in your class. Okay, how to write this statement? How the easiest way we can write? First, c of x is given. C of x has a calculator, and f of x comma y, x and y are friends, and the domain is both x and y consisting of. Okay, from the side, the statement says that first one, the symbol is for every or for all. Whatever you can write, for all, for every. So for every student x, that is for every student in x in your school, x has a calculator. C of x na x has a calculator. So, or there is a student y, such that y has a calculator. I think the symbol is or in a disjunction. Disjunction. I think that's why I can write or there is a student y such that y has a calculator and x and y are friends. Y has a calculator and x and y are friends. I think this is the disjunction one. This place is a disjunction. That's why I can write for here all. So for all x, that is for every student x in your school, x has a calculator or disjunction, or there is a student y. The C of y meaning there is a student y in your school. Whatever you can write or not write. There is a student y such that y has a calculator and conjunction meaning and x and y are friends. F of x comma y meaning x and y are friends. That is a statement converted into English sentence. This only is a disjunction. Suppose conjunction meaning we can write and x has a calculator and there is a student y such that y has a calculator and x and y are friends. In case here you can put and meaning this is the correct. Here all I can put, that's why here is a disjunction will come. So this is sometimes they can ask me for 2 mark problems. Either 2 mark or in the part B, 8 mark problem they can write the subdivisions. They are writing for subdivisions, 4 subdivisions, 2, 2, 2, 2. Or sometimes they can ask me for 4, 4, 4, 16 marks. Like versa. Next, one more example. Express the statement. Everyone has exactly one best friend as a logical expression involving predicates, quantifiers, with a domain consisting of all people and logical connectives. So all the people you can take it as a domain. Everyone has exactly one best friend. That is a very nice question. The word is exactly is most important in this place. So everyone has exactly one best friend. How the meaning of this one? Exactly one best friend. If A, B, C, 3 students are there, A has a best friend of B. Our B is not a best friend of anyone because everyone has exactly one best friend. Only one best friend. So everyone has exactly one best friend. A has the best friend of B. B has a best friend of A. Like there is no other. A and B are related. So the statement everyone has exactly one best friend can be expressed as for every person X. And here is giving is a people, all people. It's not a school students or college. Suppose the word is given is a the domain is consisting of all the students. And then you can write for every student X we can write, or every person. Here is not giving anything. Every people X normally can write. That's why I can write person singular. The pluralic people. So for every person X, person X has exactly one best friend. That is every person, that is every one meaning I can write the variable introduced. Every person X has exactly one best friend. To say that the above statement, how we can write X has exactly one best friend means that there is a person Y who is the best friend of X. Suppose you can take it as I told you A and B, here I can take it as X and Y. So there is a person Y who is the best friend of X. And furthermore, that every person Z, third person, ABC meaning A is the best friend of B and B is not a best friend of A and B. And that is that for every person Z, if person Z is not a person of Y, that is the main thing. Y and Z are not same. Z is not person of Y, then Z is not the best friend of X. And X has only exactly one best friend. X has a best friend of Y, no other friends is a best friend. In a class, around 50 students is there, meaning one has only one best friend, meaning remaining, suppose one is a fixed, out of 50, one fixed, remaining 49 students is there. Out of 49, only one is the best friend. Remaining 48 is not a best friend of the particular person. That's why I can take it as. Then only we can say the word exactly. If it is not given exactly meaning, it's okay. No need to write these steps. So if a person Z is not a person of Y, that is the main thing. The distinct from the best friend. Then Z is not a best friend of X. This now we can convert it into symbolic form. Let B of X comma Y. Y is the best friend of X. That's why I can write the symbol as B best friend. B of X comma Y. Y is the best friend of X. Or you can write X is the best friend of Y. That is your convenient, you can write. That's why I can write B of X comma Y. What you can write the way. Then X has exactly one best friend. That is a statement. Now, there X is a Y. First of all, I can write there X is a Y such that X is a best, Y is a best friend of X, and for every Z, for every person Z, Z is not a person of Y. That is Z not equal to Y. Then Z is not a best friend of X. Z is not a best friend of X. That is the negation I can write. So Z is the first term. In the place of Z is not a best friend of X. That's why I can write the negation. So there X is here. X has exactly one best friend, meaning this statement. X has only exactly one best friend. Question statement for every question statement, everyone has. I can write only X. X has exactly one best friend. So best friend I can write. There X is a Y. There X is a person Y. Such that this symbol meaning normally can write such that X is a Y is a best friend of X. You can say Y is the best friend of, I am the best friend of one student. And another person is Z. For every remaining 48 students, I told you. That is a for every Z meaning not a Y. That is a remaining 48 students for every Z. Z not equal to Y. Z not equal to Y. Then negation of B of X comma Z. Z is not a best friend of X. But now the complete statement in the question. Exactly. So everyone has exactly one best friend. Everyone. First one I can say the specific person X. Here everyone. So the X is giving here X is a free variable, not bounded variable. Now I can give some bounded things. Everyone has, that is a bound. That's why for every X, then you can write the same statement. There X is a Y. For every X, every student in your class has exactly one best friend. All the others are is not a best friend of you. That is for every X, there X is a Y, B of X comma Y conjunction for all Z, Z not equal to Y, then that is a conditional negation of B of X comma Z. Repeatedly you can do more problem, then only you can easily identify my simple statement, but everyone has exactly one best friend. It's a simple word, only one sentence, but here we can use the three variables That is the main important for this. One more example for if L of x comma y, this is I can pick from the I think Vivekanand book also. If L of x comma y symbolizes the statement x loves y, where the universe of discourse for both x and y consists of all people in the world, translate the following English sentences into logical expressions or symbolic form you can write. Okay, there are 5 sentences are given. Everybody loves Z. X and Y meaning L of x comma y, they can giving X loves Y. Here the same one, X loves Z. There is they specified the person is Z. So X loves Z. Everybody, so bound. They are giving the bounded variable. So that's why you can write for all X. Everybody loves Z. Z is fixed. Z a person is fixed. Everybody X is the bounded variable. Z is a free variable. So for all X, L of x comma Z. So X loves Z. For all X, you can change the X value, X1, X2, X3, like etc. That's why for all X, everybody it's a bounded variable. So for all X, L of x comma Z. Next one. Everybody loves somebody. There are 2 bound variables as given. Everybody loves somebody. So for that, for all X is a true for all X and some Y. Hence, for all X, I think here X is missing. For all X, both X is a bounded and Y also bounded. The first statement, Y is fixed, Z. Here, both are bounded variables. That's why for all X, there X is a Y. Somebody, let's say there X is Y. Somebody meaning anyone. There X is a Y. L of x comma Y. Okay. Here for all X, again insert the value X. Okay, next. Next one. There is somebody who everybody loves. I think more the statements are same. B and C are same, but importance is given. First is somebody. Negation is given only as a somebody. So there is somebody whom everybody loves. So even though C is the same as B, the stress in the existence of somebody Y, whom all X loves. About this only can interchange. There X is a Y first. For all X next, L of x comma Y. Already I told what is the preference of the quantifiers meaning left to right. Last class I told you left to right. Same for preposition. What is the preferences meaning? First negation, then conjunction, that's disjunction, conditional, biconditional. This is the order. Here we can go for left to right. So left meaning first negation, then first there X is a Y, next for all X. That's a stress for first. Here stress for every. Here stress for somebody. That's why there is a left and right. So not both are same. There X is a Y for all X. For all X there X is not a same. Actually stress is given for somebody. That's why this term is most important. Okay. Nobody loves everybody. Nobody meaning negation will come. Nobody loves everybody. Okay. So but there is not one who loves everybody. But there X directly can write nobody loves everybody. So for all X, there X is a Y. Negation of L of x comma Y. So X is not X not loves Y. So but therefore all everybody loves nobody. Then last sentence. The sentence means that there is somebody whom everyone does not love. The sentence means that there is somebody whom everyone does not love. Actual statement is there is somebody whom no one loves. There is somebody. But there X is a X. There is somebody. That is there X is a X. There is somebody whom no one loves. Everyone for all X. Negation of L of x comma Y. The statement will be changed as here for all X. Here there X is a X. There X is a Y for all Y. These are the statements are giving like that way. And so one more examples. Okay, express each of the following statement using mathematical and logical operations, predicates and quantifiers, where the universe of discourse consists of all computer science students or mathematics course. All computer science students mathematics course. Okay. Every computer science students need a course in mathematics. Every computer science students need a course in mathematics. First of all, I can take it as m of x. X is a course in mathematics. X needs a course. X meaning some students. Sometimes we can write this is also, I can take S of X. Here is not writing in the book, but S of X. X is a students of in your college. I think they won't specify anything. Where the universe have discussed of all computer science students, they are specified. X nale computer science students they can specify. Okay, upon that no need write the S of X, no need. Generally they can giving the students meaning you can write S of X is just. Okay. So let M of X. X needs a course in mathematics. Where the universe of discuss consists of all computer science students. All computer science students need a course. If X is a computer science students need a mathematics course. M of X meaning X needs a mathematics course. For all X, M of X. For all X, M of X. X needs a mathematics course. Okay. Second one. There is a student in this class who owns a personal computer. There is a student in this class, so who owns a personal computer. One more term, who own a personal computer, that's why I can take it as the variable predicates P of X. X owns a personal computer. So as the universe have discussed, there is a student. There X is a X. There X is a X. Who own a personal computer P of X. There X is a X, P of X. Let Q of X comma Y equal to, next one, every student in this class has taken at least one mathematics course. Every student meaning for all X. Every student for all X in this class has taken at least, that is a sum one, there X is a mathematics course. So for Q of X comma Y meaning X has taken, confirmed as mathematics course. X has taken a mathematics course. So the universe of X consists of all the students in this class and that of Y consists of all mathematics course. So taken Y, Y is the mathematics course. So there X is a Y for all X, at least one mathematics course. I think lot of mathematics course meaning you can choose one. That is a one. Y meaning mathematics course. So for all X, there X is a Y. So Q of X comma Y. X has taken, that is a X meaning bounded variable for all. So for all X has taken, there X is meaning at least one mathematics course is Y. That is a statement. Last one. There is a student in this class who has taken at least one mathematics course. There is a student. C is every student in this class. But same one, C and D are same. Here the bounded variable is universe of discuss. Here I can use the thing there X is existential quantifiers. So we have there X is a X, there X is a Y, Q of X comma Y. That's all. So this is for the previous one. Next one. So these are some examples of the predicates and quantifiers. Mostly they can asking for either 2 mark or in the subdivision of 8 mark sums. Okay, next we will go for very most important topic of this units. And because the same one, logical equivalences we can prove. Previously we can show that logical equivalences by using truth table and also without using truth table, using the commutative law, associative law, distributive law, identity, idempotent law, absorption law, very rare cases, rare problem we can use it. Negation or complement. Another name of the negation or complement. Negation law, complement law, De Morgan's law. These are the laws we can using. We can prove the statement. Left hand side you can take. We can bring the RHS. Rules of inference also the same method we can write for here. And also rules of inference also quantifiers also we can include. Okay. What is the rules of inference as a definition? Inference theory. The main aim of logic is to provide rules of inference or principle of reasoning. Here we are concentrate with the inferring of a conclusion from the given premises. That's why I already told the first class. Premises meaning the simple statement without connectives. P, Q, all, S. That is a statement. A and B. So premises meaning question itself is given by putting comma. P conjunction Q, comma P, comma Q disjunction negation or comma and the conclusion. These are the premises. Premises is nothing but a hypothesis. By giving us a comma. Conclusion from the given premises, we are going to check the logical validity of the conclusion. So from the given set of premises, that is a hypothesis, by making use of equivalence rule and implication rule, Implication meaning only one side is true. Once you can take the LHS, RHS will be derived, but converse is not true. RHS is true, we cannot prove for LHS. That is a if-then statement is called implication. If-then, and the converse also if-then, that is called conditional. That is if and only if is biconditional, normally we can say. The theory associated with such thing is called inference theory. These are the formula we can using for rules of inference. The very most important formula: modus ponens, model tolerance, hypothetical silosium. These three things maximum I can using the maximum problem. Simplification also one or two problems, and disjunctive silosium also one or two problems. First three is we can use most of the problem we can using the first three. So just rule of inference. Rule of inference, a tautology name. Already I told you how to prove the tautology. The implication statement you can put in the truth table or without using truth table. Final answer without using truth table, final answer T will come. Using truth table, the last column completely T will come. Truth value will come. No false value. All are true. That is a tautology. So first one, this is the sum of the books they can using like this way. The same statement only I can write for here. The conclusion is I can write implication. The conclusion, underline the two line. The conclusion is implication. These two things are addition. That is a multiplication. These two things. That's why I can write conjunction. P and P tends to Q. That is a P and P tends to Q. We can write Q. You can simplify. You can get the value. Actually, directly I can write upcoming problems. Modus ponens meaning P conjunction P tends to Q. I can write the formula Q. P comma P tends to Q. Either I can write P comma P tends to Q, or P conjunction P tends to Q, or P and P tends to Q. Three ways we can write: P and P tends to Q, P comma P tends to Q, P conjunction P tends to Q. This in this place the left hand side is there. Instead of this value I can write Q. How this is? For example, P tends to Q, I can write negation P, disjunction Q. Normally we can write negation P, disjunction Q. So one conjunction, one disjunction, then we can apply for distributive law, we can study. So go for distributive law and then simplification or tautology. This is called modus ponens, model ponens. So P comma P tends to Q. Absorption law, you can remember. P comma P tends to Q, we can write the answer is Q. That is modus ponens. And negation Q comma P tends to Q. Here P common, that's why I can write the answer is Q. Q and negation Q will come, I can write negation P. So negation Q, conjunction P tends to Q, or negation Q and P tends to Q, I can write negation P. That is a modus tollens. And the very most important silosium, P tends to Q and Q tends to R, or P tends to Q, comma Q tends to R. That's why I can write P to R. That is a biconditional we can prove. P to R. Hypothetical silosium. P tends to Q and Q tends to R. We can write the conclusion as P tends to R. In case any other problem, P tends to Q, comma Q tends to R is there. Next step I can write by it is some. I think this is the second step. We can take it as this is the third step. So from second and third step, I can take the conjunction. I can write this formula by using comma meaning like conjunction. P tends to Q, comma Q tends to R. I can write P tends to R. We can write mention. I think some of the homework, some of the students is not mentioned the llama. Please try to mention each and every step. You can write the what law you can use it. So distributive, associative, any law you can using, or two laws using in the same step you can write. So try to write all the steps. But exam point of view, we are evaluation purpose, we cannot check all the steps step by step. It's not possible for us. There is no other time, because different way we can write. Some students once you can take associative, then apply distributive. Some students apply the distributive, then take associative. So we are expecting only for the final answer. Most of them we can expecting final answer. So that's why you can write others. Try to know the name of the laws. Suppose if you don't know the name of the law, you can leave it, no problem. The final answer only we are expecting. So try to conclude the final step is very most important. The exact answers we need. Okay. I think some students are asking first I can find the PCNF, then I can able to find out PDNF. No problem. Whichever the easy for you first, you can do it the first one, then you can take the other one. But question they can specify it, find PDNF, hence find PCNF meaning that is first choice you can find the PDNF. Next step you can find PCNF. That is the meaning. If they won't specify meaning, you can go for PCNF to find PDNF or PDNF to PCNF, which is your convenient. D for disjunction. Outside of the bracket, disjunction will come. Inside the bracket, conjunction will come. That is a PDNF. If it is a PDNF, we can write the conjunction true only. We can add third variable. For PCNF, outside is conjunction, inside is disjunction. So disjunction meaning you can write false value PCNF. Okay. So hypothetical silosium. Next one, disjunctive silosium. P disjunction Q and negation P and service Q. P disjunction Q and negation P, we can write. This is commutative law also you can apply, no problem. First negation P and P tends to Q. That is also is okay, no problem. But this is we cannot change. So P disjunction Q and negation P. Then we can write Q, disjunctive silosium. Next, addition law. P, that is we can write insert Q also possible. P or I can add Q. So instead of P, I can write P disjunction Q. Instead of P, I can write P disjunction Q. That because addition. Addition meaning tautology. P tends to Q, we can take a truth table. Answer will come tautology. Last column completely we can come tautology. So P instead of P, I can write P disjunction Q. This is addition. Extra one term I can add. That is a disjunction Q. Another one simplification. Two terms I can convert it into single term. P conjunction Q, I can write P. The P conjunction Q, I can write only P only is possible. So why I can't write Q? You can check. P conjunction Q, what is the answer? P conjunction Q meaning either one of the value true, the output is either one of the value false, the output is false. So first statement only alone, first statement alone true. All the other statement are false. So true, false, false, false. So next P you can take it as simplification. So you can go for P true, triple false, and then P value true, true, false, false. So conditional you can take it as answer is tautology will come. Suppose if I can take it as this term as Q instead of P, if I can write Q, simplification I can write Q. Q meaning, so here this truth table of this one is true, triple false. And if you can write Q, true, false, that is also is possible. Simplification Q also I write. Tautology will come, you can write this possible mark. Because here true and the remaining three is false. True, false only is for true, true is true mark. True, false only false for simplification. This is I can write Q also mark. P conjunction Q I can write P or Q. That is simplification. Addition, additional one term I can add it. Simplification, additionally one term, reduced one term. Then conjunction P and Q, comma meaning and P and Q, conjunction P comma Q, we can write P conjunction Q. Last one, resolution. P disjunction Q, negation of P disjunction Q, negation P disjunction R, we can write Q disjunction R. That is a resolution. I think I didn't use most of the problem. Very, very rare cases we can use this one. P disjunction Q, conjunction, negation P disjunction R. Okay. These are the rules of inference. So compulsory you have to remember these formulas. Some more examples for here. State which rule of inference in the basis of the following arguments. It is below freezing now. Therefore, it is either below freezing or rain now. So let P, it is below freezing now. Q, it is raining now. So now I can take for addition. P disjunction Q. This is an argument that uses the addition because here the term. Here it is below freezing now. Therefore, it is either and it is either below or rain now. The disjunction. Using the addition rule, here I can addition for conjunction, I can add disjunction. Either you can using conjunction and you can using for disjunction, P disjunction Q. So P disjunction Q I can write for here. One more here. Rules of inference theory. That is a very most important rule. Rule P, rule T, rule CP. Sometimes 8 mark they can using the rule CP applied formula problem only they are asking. For 8 marks we can more concentrate on rule CP. First one, rule P. A premise may be introduced at any time in the derivative. For example, the hypothesis. Normally we can use given. Normally we can write the statement as given. That is the call is for here rule P. Wherever we can write the given statement. Question LHS if we can take it as we can write given. The in between side we can write the reason is we can write rule P. Don't write given statement. That is called rule P. What rule you can apply? The given hypothesis or the given statement, that is you can take it as rule P. Suppose you can apply any formula, distributive, associative, identity, or otherwise hypothetical silosium, disjunctive silosium, model tolerance, model ponens. These formulas you can using to derive the hypothesis, apply the rule T. That is a rule T meaning a formula S may be introduced in a derivation if S is here. Yeah. Anyone have the doubt? I think someone is unmute. No. So yes. So S may be introduced in a derivation if S is tautologically implied by any one or more of the preceding formulas in the derivatives. If we can apply the formula, then you can use for rule T. If you can use the hypothesis or the given statement, you can use for rule P. Okay, this is the rule P and rule T. Next for rule CP. If we can derive S from R and a set of premises, if we can derive S from R and a set of premises, then we can derive R tends to S from the set of premises alone. That is called rule CP. If we can derive S from R. So R we can using S, some formula you can using, then you can write S. That is a S is derived from some R and a set of premises. Some premises and the given question you can using for R. Then we derive R tends to S. Again using the R. Once again, 2 times I can using the problem. Hypothesis I can take it as 2 times. R tends to S from the set of premises alone. That is called rule CP. Sometimes problem you understood. Only one problem we can see, it's enough for today class. So how we can write? Show that all disjunction S follows logically from the premises, follows, not equivalence. So understood the statement is follows meaning is a implication. Left hand side and the right side we can bring, not the converse. Okay. Show that all disjunction S follows logically from the premises. These are the premises is given. C disjunction D, comma C disjunction D tends to negation P. Second premise. Third premise, negation H conditional A conjunction negation P. Third. And the last one, A conjunction negation P tends to R disjunction. So 4 premises compulsory, 4 times you can apply the rule P. In a 4 given statement, we can use this formula. The 4 given statement, we can use this formula. That's why you can go for 4 things. So you can apply for 4 times. You can write rule P compulsory 4 times will come. That is a given. Okay. Now I can start the step. Final conclusion. I need R disjunction. Yes. We can using for implication steps. Sometimes they can write for serial number 1, 2, 3. Here the what type of rule you can follow. Sometimes you can write the heading as rule also. Here the reason. What you can using the laws. First, I like to take the start the given start pananum. Appo given na there are 4 premises is there. I can choose any one of the premises for my convenience. So I can see that P tends to Q. Q tends to R. What rule for here? What rule apply for here? P tends to here. See that P to Q, Q to R. Then I can write P to R. Hypothetical silosium. This only I can apply for here. Here they see that P, Q, Q, R. That's why I can write first step is C disjunction D, conditional negation P. That is a rule P given. Negation H tends to A conjunction negation P. Rule P also given. These 2 I can apply for hypothetical silosium by rule T. Formula apply pannaala rule T. R and D. Again I can apply for hypothetical silosium for here also you can check. So this rule P, I can take it as for here A conjunction negation between order. From these two things, again I can apply for hypothetical silosium. C disjunction T tends to R disjunction here. Now I can go for the first rule P. See, P comma P tends to Q. P comma P, this is the P. Step 6 and 5, not 5 and 6, step 6 and 5. P comma P tends to Q. See that? P comma P tends to Q. Model ponens. P comma P tends to Q, we can write Q. That's all. R disjunction S will come. Only the two things, hypothetical silosium, 2 times I can apply it, and then model ponens I can apply it 1 times. This is the things now. So that's all. That is the answer is clear. This is the rule of inference, logical equivalences. This is a comma meaning. The same problem they are asking by the proposition calculus. They can remove the comma by conjunction, and final step implies or disjunction S is given. Implies or disjunction S is given. So these are the rules of inference. Normally you can using for rules of inference. This is the formula. Okay, up to this we can see. So if anybody has a doubt, you can clarify, ma. So remaining 3 or more problems is there. Next class we can do that problem. That is easy. Next class, if it is possible, I can do it in the board itself. Okay, if anybody has a doubt, please try to clarify if anybody has a doubt.